Hello my dear students, welcome to my channel The Report Card, and I am again back with another set of my video on a topic where I will be talking about the formation of some electrovalent compounds. This video is again made on special request by some students of grade 10th cbse, and they wanted me to make a video on how the ionic bond structure is formed and how do we represent it through an electron dot structure diagram. Okay, so after a long time I am coming back with this set of video, but yes, I think this you will find this video very useful. Now in my previous video related to this topic only, I discussed the octet rule and the duplet rule. Okay, so please watch my previous video to clarify these two rules, because unless and until you clarify these two rules, you will not be able to understand this. Okay, so please watch my video on this particular topic, the part 1 I must say, where I have told you about the octet and duplet rule. Okay, so now I will be talking about how some electrovalent compounds are formed. Now I told you that every atom it tries to attain its stability. Okay, and for that it always tries that if it has got more than one shell, then the last shell should have 8 electrons, or the shell itself is vanished, or the shell itself is removed from that particular atom. And if it has got just one shell, then it should have either 2 electrons, or the shell should completely vanish. Okay, so this is how the atoms basically they work. So what happens when an electropositive atom comes in contact with an electronegative atom? Okay, now this is what I'm going to talk about. What if the atoms having two extremes in relation to the number of electrons which is present in its outermost shell, when they meet together, what type of bond form, how do they behave, right? And this is what we are going to study, and I have just taken 4 examples over here: sodium chloride, magnesium oxide, sodium oxide and magnesium chloride. Okay, so let me just talk about the formation of sodium chloride first. Okay, let's start with sodium chloride. Now we know that sodium has got 1 electron in its outermost shell. How come sodium has got 1 electron? The atomic number for sodium is 11. Okay, and that means that sodium has 11 protons and 11 electrons, because sodium is a neutral atom over here. Okay, so when there are 11 electrons in sodium, so if you look at the distribution of electrons, it would be something like this. Now 2 in the first shell, 8 in the second shell, and 1 in the third shell. Okay, now and when we are looking at chlorine, when we are looking at chlorine, the atomic number for chlorine is 17. Okay, so that means it has got 17 protons and 17 electrons. Okay, so this the electronic configuration for chlorine would be something like this: 2, 8 and 7. Okay, so the outermost shell of chlorine has got 7 electrons. Okay, now let us just make an electron dot structure. Now when you are making an electron dot structure, mind it that you are not going to show all the electrons. You are just going to show the electron which is there in the last shell or the valence shell. Okay, so sodium, I am going to represent the electron like this with a cross. As you can see, its valence shell has got 1 electron, and when it combines with chlorine, now chlorine has got 1, 2, 3, 4, 5, 6 and 7 electrons. Okay, so this is how I have represented the number of electrons which chlorine has, right? Now what will happen when they both will combine? They both will get a chance to satisfy themselves or to become stable. How? Sodium will donate one electron to chlorine. Okay, because it has got one electron in its outermost shell. So if this one electron is donated, then what will happen? It has got 8 electron in its outermost shell. Then sodium will become stable. Okay, so that's why it will donate one electron to chlorine, right? And now chlorine will gain this electron. Now what will happen? Now sodium, once it donates one electron, it will definitely gain a positive charge. It will gain one positive charge. Okay, and now I am not showing 8 electrons because sodium's outermost shell is completely removed, so I am not going to show anything, right? Now here what will happen? What about chlorine? Now chlorine, it will have 1, 2, 3, 4, 5, 6, 7 and 8. Now one electron is from sodium and it will gain a negative charge. Okay, it will gain a negative charge, right? So one positive and one negative charge because it has got one electron. One electron is added to it. Okay, so now what will happen? It will become something like this: Na positive, and there would be a bond formation with negative, and it will become NaCl. Okay, so this is how the formation of sodium chloride takes place, right? So this is how you are going to represent it with the help of an electron dot structure. Clear? So this was for sodium chloride. Now let us just move on to the next one, that is magnesium oxide. Okay, so I am just going to erase this. Now let us talk about magnesium oxide. Now in magnesium oxide, see, MgO, this is it. Now if we look at magnesium, magnesium's atomic number is what? 12. It is 12. Okay, so 12 means 2, 8 and 2. Okay, 2, 8 and 2. And what about oxygen? The oxygen atomic number is 6. So it will, it is not 6, it is 8. Okay, so it will be 2, yes, and 6. 2 and 6. Okay, so it is 8. So atomic number of oxygen is 8. So outermost shell will have 6. 6 plus 2 is 8. Okay, now what do we see? If we see magnesium, it has got 2 electrons like this. Okay, but if we see oxygen, it has got 1, 2, 3, 4, 5 and 6 electrons. So oxygen needs 2 electrons to complete its octet, while magnesium will of course require around 6 electrons, which is not possible for it to gain. Okay, so what will magnesium do? Magnesium will donate both its electron to oxygen, right? So both the electrons will be given to oxygen. So what will happen? Magnesium will gain up 2 positive charges. Remember, because it has donated how many electrons? 2 electrons. Okay, so there would be 2 positive charges over here, and oxygen with 1, 2, 3, 4, 5, 6, 7 and 8. Okay, 2 electrons it got from this magnesium, so it has got 2 negative charges. So 2 positive and 2 negative charges, again they will have an electrovalent bond. Okay, there will be a bond formation between them, which is an electrovalent bond, and we will get MgO. Okay, so this is how the formation of magnesium oxide takes place. Okay, right. So let us move ahead and now look at the other compound. What was it? It was sodium oxide. Okay, the other compound was sodium oxide. Now what is sodium oxide? Na2O. Okay, so here we have sodium. Again we know, we had already done the electronic configuration for sodium is 2, 8 and 1, and for oxygen it is 2 and 6. 2 and 6. Now here what happens is, that oxygen require 2 electrons. Okay, and one atom of sodium will only be able to donate 1 electron to oxygen. So oxygen will always search for another atom of sodium. Okay, so instead of combining with just one atom of sodium, oxygen will combine with 2 atoms of sodium, so that both the atoms can give them one electron, give them in the sense give oxygen, okay, one electrons, and oxygen will attain its octet, while sodium will also get satisfied because its outermost shell will be removed. Okay, so let us see how this happens. Over here we have sodium with 1 electron, then we have oxygen with 1, 2, 3, 4, 5 and 6 electrons, and then again there is one more sodium, right? So this is something like this. So what will happen? This sodium will donate 1 electron and this sodium will also donate 1 electron to oxygen. Okay, so as a result of this donation, sodium will gain a positive charge. So you can just write down 2 sodium atoms. Okay, 2 sodium atom will gain a positive charge, and there would be an oxygen 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and it will gain how much? It will gain 2 negative charges because it has got 2 electrons. Okay, so what will happen this way? So sodium, either you can just write like this, and you know you can write like this, Na positive, there would be a bond with oxygen, negative negative, and there would be another Na positive. Okay, so you can write it like this, or you can even show like 2 Na positive and oxygen 2 negative. This way also you can show that there is an electrovalent bond formed and it will form Na2O. Okay, so this is how the formation of sodium oxide happens or takes place. Okay, now let us come on to the last compound which I am going to tell you, and then you can just practice more. We have magnesium chloride. Magnesium chloride is MgCl2. Okay, now in this again, when we look at magnesium, it is 2, 8 and 2. Okay, the electronic configuration for magnesium, while for chlorine it is 2, 8 and 7. Okay, so chlorine actually require 1 electron, but there are 2 magnesium. Magnesium also needs to satisfy itself. So when it comes in contact with chlorine, so magnesium would require 2 chlorine atoms. Okay, so that it can donate both the atoms. Otherwise, just donating 1 electron rather, it can donate both the electrons, not atoms. So just donating 1 electron will not do. It will not stabilize magnesium. It will not. So magnesium needs to donate both the electrons, then only it will become satisfied, okay, or stable, right? So what will happen? Magnesium is going to combine with 2 atoms of chlorine. So here again we can write magnesium with 2 electrons and chlorine 1, 2, 3, 4, 5, 6 and 7. Another chlorine 1, 2, 3, 4, 5, 6 and 7. So 1 electron here and 1 electron here. So magnesium is going to donate the electron, okay, and it is when it is being added, okay, when there is a reaction happening between them. So we have chloride ion with 1, 2, 3, 4, 5, 6, 7 and 8. It has got a negative charge. And then we have magnesium with 2 positive charges. Then there is another chloride ion. Okay, I don't have space here, so I'm just making it like this: 1, 2, 3, 4, 5, 6 and 7. And then there is a negative charge. Okay, so what will happen? There will be a bond formation. Now it is chloride ion, okay? Chloride ion. There is a bond formation between chloride ion and magnesium ion, and this is MgCl2. Okay, so this is how the bond formation happens, right? So these type of compounds, they are known as electrovalent compounds, okay, because they have got, their bond is electrovalent, something related to electricity, something related to charge. So a bond formed between two opposite charged ions is actually called as an electrovalent bond, and the compounds which are formed as a result of such bond formations are known as electrovalent compounds. And these electrovalent compounds are very good conductors of electricity in molten state or when they are dissolved in water, because they carry ions. Okay, so whenever they are dissolved in water, they just break into their ions, and you know that ions, movement of ions is basically or charged particles is actually the electricity. Okay, so this way they become good conductors of electricity, and their bond is very strong because it's a bond between two opposite charges, so it's very difficult to break these bonds. Okay, so they are very strong, so you need to heat them if you want to, you know, break the bonds. You have to heat them to a very high temperature. They are mostly solids and brittle. It is just because of the bond formation, because the bonds are very strong, right? So that's why there is no what I may say, loose connections or gaps between the particles. Therefore they are actually solid. Understood? So this was all about the electrovalent compounds and the electrovalent bond formation. So now I believe that you all are aware of it and you will be able to make these electrovalent bonds. Fine. Thank you, class.